Hybridization. You must have heard about this term. What does this mean? Hybridization is intermixing of atomic orbitals to form hybridized orbitals. Intermixing of atomic orbitals to form mixed orbitals, or we call them as hybridized orbitals. Alright, I'll give you a small example. If you have, let's say, four walls in your room and you want to paint three walls with purple color and one wall with saffron color. Saffron is just like orange. So one with saffron color and three walls with purple color. What you will do? You will get three, and each wall takes one paint box. Okay. So what you will do is you will get three purple paint boxes and one saffron paint box. Now your dad comes in and he says, no, 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 nothing doing. You have to paint all the walls. We are getting painted all the walls with the same color. So what you will do? You don't have a choice. Seriously, right? In front of your dad, you don't have a choice. So what you will do? You will only have option to mix all the paint boxes in a big container. Three purple paint boxes, one saffron paint box, you will put in a bigger container and you will mix them, right? So we took three purple, one saffron. Now you, after mixing, how many paint boxes you will have of the new color? I I think you will agree with me. You put in three purple, one saffron. Overall, you put in four paint boxes, and after mixing, you will get four paint boxes, and each one will have the same color of paint, and the same properties of the paint will be there in all four paint boxes. The new ones you get. Now you can have all four walls of your room with the new colors. Now, similar thing happens when central atom is going for hybridization. So, orbitals of the similar energy, they undergo mixing. For example, if one s orbital mixes with three p orbitals, one s, three p orbitals are getting mixed. How many orbitals? One s, three p. Total four orbitals are undergoing mixing. Now, after mixing, how many new orbitals will be formed? New mixed orbitals. These mixed orbitals are called hybridized orbitals. I think you will agree, when four orbitals are overall getting mixed, new orbitals formed will also be in four. The number will be four, right? And each one out of four orbitals will have same properties, same bond angle, same shape, same as orientation, right? So this is the concept of hybridization. Now, how the names come? If one s orbital is mixing with three p orbitals, then after mixing, four orbitals are formed. Each one will be 1s 3p. So from that we give a new name sp3. If 1s 1p, after mixing you will get two new orbitals, and those will be, both of them will be called as sp orbitals. 1s 2p orbitals. Now the new orbitals will be sp2. 1s 3p, right? 1s 3p orbitals. Now mixed orbitals will be called sp3. Similarly, sp3d, sp3d2 are named like that. So how you will find out which molecule or which central atom has sp orbitals after hybridization, sp2, sp3? So we have a formula for that, which we are going to discuss over here. Let's see. Check out this formula where number of hybridized orbitals is represented by H, number of hybridized orbitals. So H equals to half of V plus M minus C plus A. I will explain each and every term out here. H is number of hybridized orbitals formed after mixing. V is number of valence electrons in the atom. M is number of monovalent atoms in the molecules. And C is charge on the cation. A is charge on the anion. Right? So if you add these values for a molecule, you get the value of H. And if H comes out to be 2, you will say hybridization is sp. If H comes out 3, you will say hybridization is sp2. If it comes out to be 4, you will say sp3. If it is 5, you will say hybridization is sp3d. And if it comes out 6, you will say sp3d2. So these are few types of hybridization that is being found in the natural molecules. Right? For example, we have taken few examples over here, such as CH4. CH4, number of valence electron on the central atom carbon is 4. How you will find out that? Just remember the last digit of the group number. Carbon belongs to group 14. So number of valence electron on carbon is 4. If any molecule has, let's say, NH3, the central atom is N. N belongs to group 15. So number of valence electron will be 5. So last digit of group number usually represents valence electrons in S and P block elements. Now, so carbon has 4 valence electron and hydrogen is a monovalent atom. So 4 plus 4, it is a neutral molecule, no value of charge, right? So you will get half of 4 plus 4, that is 4. And 4, I told you here, if H comes out to be 4, the hybridization will be sp3. Similarly, in PCl5, the P belongs to group 15, so valence electrons are 5, and Cl is monovalent atom. So how many monovalent atoms you have? 5. And there is no charge, so half of 5 plus 5 comes out to be 5. So hybridization in PCl5 is sp3d. Similarly, in S sub 6, S belongs to group 16. So number of valence electron in sulfur is 6. And fluorine is monovalent atom. How many monovalent atoms do you have? 6. And the charge is 0 again. So half 6 plus 6 comes out to be 6. So hybridization is sp3d2. Alright, I hope we have successfully understood what hybridization is and how to find out hybridization in given molecule. That's it.